Today's lesson will be looking at Chemistry 1501. The topic for today will be ideal gases. This is lesson 101, and then our main focus for today will be based on this equation that we see here, which is PV is equals to nRT. Let us start. PV is equals to nRT. It's one of the ideal equation that we use, especially to calculate stoichiometric calculation questions. Now, it's very important to know how to use this equation and to know the SI units of each of these physical quantities. Now, let us start by explaining each of these variables that we see here. P is the pressure, and then V is the volume, N is the number of moles, then R is gas constant, and then T is our temperature. Now, in this lesson video, we are not going to go through the practice questions on how to apply this equation. What is important is to know the SI units of this equation. Now, I know that it might be difficult to master the SI units because you know that, let's say for example, pressure, it has multiple of or a number of SI units: kilopascals, atmospheric, pascals, or torr. So it's very important to know which proper SI unit to use in this equation. So we are going to do, let me say, a trick on how to master the SI units of these physical quantities. Now, you said the equation is PV is equals to nRT. The goal lies with this R. Let us make this R the subject of the formula. So we are going to divide both sides by NT. Then we are going to get R is equals to PV over NT. So you should know that the value of R, which is the gas constant, we can use 0.082 liters multiplied by ATM, that is the SI unit, multiplied by K, multiplied by M1. So if you can check this, all the SI units that are raised to the power -1, they're actually from the denominator. So if you take each and every SI unit to the numerator level, you can see that their exponents will become -1. So this SI unit will actually assist us on the proper SI units for the four physical quantities. Now, the other value of R can be 8.314 liters K pascals divided by K mole. So if we have this, then it means the SI unit for volume should be in liters. As you can see, this L, it's in liters. Remember that the SI unit of this will be the combination of these four physical quantities. So since we can see ATM, it means the pressure must be in ATM. This is the volume, this will be the pressure. And then K means Kelvin. It means that our SI unit for temperature should be in Kelvin, that is the temperature. And then for the number of moles, it should be in mole. So you can see that the trick lies with this R. And then looking at this value, we can see that L is our V, volume must be in liters, doesn't change. And then if you are given the pressure in terms of kilopascals and then you don't want to convert. So it means if the pressure is given in kilopascals, you are going to use this value for R. If it's given in ATM, you are going to use this value for R. So you can see that temperature remains Kelvin, and then the number of moles remain as mole. So it's very important to convert, let's say for example, from milliliters to liters, from degrees Celsius to Kelvin, from kilopascals to ATM, or from torr to ATM. Let's start with conversion factors of temperature. Now the equation to convert from degrees Celsius to Kelvin is given by this equation. So let's say for example, we want to convert 10 degrees Celsius to Kelvin. Simply going to take this equation, K is equals to, where we see degrees Celsius, we're going to put 10 plus 273. We're going to get 283 Kelvin. That will be the new temperature. So it means that using the ideal equation, if you're given the temperature in degrees Celsius, you should convert to Kelvin before you substitute. So you're not going to substitute 10, but you're going to substitute 283. Let us look at another example. Let's say we have 150 degrees Celsius. You want to convert to Kelvin. So using the equation, we're going to say K is equals to 150 plus 273, which will be 423 Kelvin. So this is how we actually convert from degrees Celsius to Kelvin before we substitute to that equation. Our next conversion is volume. So you should know that to convert from milliliters to liters, we always multiply by 10 to the power negative 3. So let's say we have 100 milliliters, we want to convert to liters. We are going to say 100. Where we see m, we substitute by this. So it will be multiplied by 10 to the power negative 3. Then you can see that once we substituted this by this, we'll be left with this. So you can simply put liters here. Then when you punch this on the calculator, you're going to get 0.1 liters. So this will be the value that we need to substitute when we're using the ideal gas equation. So we can also say that from milliliters to liters, we divide by 1000. It's just the same thing. If you can check 100 divided by 1000, it will give you this. And you should also know that decimeter cube is the same as liters. So if it happens that in the scenario you are given the volume in decimeter cube, just know that is the same as liters. Then you should also know that from centimeter cube to decimeter cube, we divide by 1000. Then this will actually be the same as from centimeter cube to liters. So these are the important conversion under volume that you need to understand in order to apply that equation. Now let us look at important conversion under pressure. Now you should know that 1 atm is equals to 101,325 kilopascals. Actually, the proper way to write this is kilo, capital letter P, A. Then 1 atm is also equals to 760 torr. 1 atm equals to 760 millimeter mercury. Let's look at how to apply these conversions. Suppose that you are given 200 kilopascals. You want to convert to atm. You should know that when we convert kilopascals to atm, we divide by 101,325. Actually divide by this number. So it will be 200 divided by 101,325 atm. We are going to get 1,974 atm. If we use fractions, we're going to have 200 kilopascals divided by 1 multiplied by 1 atm. It's over 101,325 kilopascals. So you can see that this will get rid of this, and then 200 multiplied by 1 multiplied by this will give you 200 atm divided by 101,325. So you can see that it's actually the same as this. Then it means that from atm to kilopascals, instead of dividing, we are going to multiply it by 101,325. So you can actually see how we convert from one conversion to the other. And this is between atm and kilopascals. Now let us look at atm and torr. In this case, you can see that it's the same as the previous conversion. From atm to torr, we are going to divide by 760. Actually, I made a mistake. It's supposed to be one way and the other. It should be from torr to atm. We divide by 760. Then from atm to kilopascals, we are going to take the previous conversion, multiplied by 101,325. So you can see that if you want to convert from here to here, you need to kind of go via atm. So let's say we have 1032 torr. You want to convert to atm. We're going to take this number, we divide it by 760, not 360. Looking at that conversion, this will be over 1 multiplied by 1 atm. So torr should be at the bottom or at the denominator level so that it can cancel out with this one. So we have 760 torr. This will get rid of this, and then we have this divided by this. So it's 1.358 atm. So this is the conversion we have between torr and atm. Our last conversion is between atm and millimeter mercury. So from millimeter mercury to atm, same as the previous conversion, we divide by 760. So a typical example, let's say 970 millimeter mercury, we want to convert it to atm, we can actually use the ratio multiplied by 1 atm over 760 millimeter mercury. So this will get rid of this. Then we have 960 divided by 760. I meant 970 divided by 760. 1.276 atm. So today's lesson video, we are actually dealing with the conversion to prepare us for lesson 102, where we look at the application of the ideal gas equation. So just make sure that you watch lesson 102 on how to apply that equation. That's it for this lesson video. This is Popular SG. Thank you very much.